So we're going to get started here. So my name is Steve Stein. I'm going to talk to you today a little bit about AI factories. I want to spend some time with you to talk through why AI factories are necessary. I'm sure you've heard this buzzword, but I want to talk to you a little bit more about specifically how us and HPE are building AI factories together and making them real. So just as a point of clarification between how NVIDIA, so I work for NVIDIA, I'm a product marketing manager for NVIDIA, and Terry's going to come up after me, CTO sales over for HPE. At NVIDIA, we like to talk about AI factories as a concept, as a way to build data centers to help kind of fuel how you can actually power AI workloads. In HPE, they make it real for you. They're going to be able to connect what NVIDIA does well, which is where we're going to be able to give you high-powered, fully optimized AI workloads, but the true power and value, frankly, of AI factories comes when you actually connect it to your business and your business data. So Terry kind of walked through a little bit more about how you actually connect these AI factories to your business and make it real. I'm going to talk a little bit more about it at a high level, why you need them in the first place. So let's start there. So I'm going to talk to you kind of about what they are, why they're necessary, but I want to start with some data points. I'm sure if you read all the AI hype articles, if you went to the keynote this morning, you're going to think every enterprise in the world is deploying AI agents, AI at scale, and receiving value back. The reality is that while 92% of the world is investing in AI, only 1% truly have mature AI deployments. Let's define that term for a second. A mature AI deployment means you've identified which AI POCs, which AI workloads actually provide you value. You've bought and scaled your infrastructure, you've installed that infrastructure, and you're receiving value back from those AI projects and those AI workloads. Only 1% of the world's organizations have really gotten there, but again, 92% are investing. That's because they see the value in AI and especially how you can actually deploy it inside your walls. And I'll talk a little bit about how the evolution of AI is starting to really deliver value back into the enterprise a little bit. But one of the major barriers, one of the major roadblocks between that 92% and that 1% is really infrastructure, scalable infrastructure, and the complexity that comes into how you actually get the right infrastructure and scale that and install it and get it usable for your enterprise and for your organization. That's the thing that's really holding a lot of these enterprises back. And we'll kind of talk about, again, how we make that real for you as you're trying to install real AI factories for your needs. And so what is an AI factory? At its most baseline definition, if you compare it to, say, a car factory, for a car factory, you have inputs of steel, aluminum, manpower, and the output is a fully assembled car. So very similar to that, for an AI factory, you have inputs of data and electricity, and the output is tokens, or rather the output is intelligence being manufactured at scale. And for those of you that don't really quite know what a token is just another word for a word. Roughly 1.3 tokens equals a word. The intelligence part comes into how you string these words together. And so that's what we're manufacturing at scale. We're manufacturing tokens that deliver value back, that deliver intelligence back into the enterprise. But again, the idea is we have electricity and data coming in one side, and we have intelligence on the other side. And HPE has a very similar view to this. Data and models being ingested into the AI factories that they're building for you, and inside of there's data ingestion, model training, inference learning and monitoring, model fine-tuning inside there, but really the output, again, is intelligence at scale across a wide range of industries and a wide range of use cases on top of that. So let's talk about why AI factors are necessary. I mean, we tried to define it a little bit, but I like to dive into a little bit more about why they really are necessary and what are some of the workload needs and what are some of the kind of the market needs that are defining why you really do need these AI factories. So let's talk a little bit about accelerated computing and where we came from and where we're going. So let's talk about the evolution of AI. So back in 2012, we learned that we could train neural networks, train image recognition neural networks on commercial-grade GPUs. That was the birth of AlexNet, that's the birth of the AlexNet competition, but that evolved into what we call now perception AI. Before generative AI, we just called it AI, we just called it deep learning. But that's your speech recognition, your image recognition, but at its core, what's happening is using AI to classify current data sets. You're not generating anything new. And so I've been in the AI industry for roughly 10 years now, and we were always kind of looking for this killer app, this thing that's really gonna start adding value back into the enterprise to really justify its investment. because AI is a very power-hungry, resource-hungry, compute-intensive workload. You need a lot of resources to run it well. So what's the value you're getting back? So then 2022 happened, generative AI took off, and for me, this is the real unlock for enterprises, because now you're not just classifying current data sets, you're actually generating new information for the enterprise to use. And so that's where generative AI, that's where agentic AI is starting to come into play. And agentic AI is just really, it's an evolution of Gen AI where you're actually allowing the LLMs, you're allowing the generative AI systems to take autonomous action. That's the main difference between an agentic AI system and an LLM. And then eventually we want to evolve into this place of physical AI, which is one of two things. Either you're simulating the physical environment inside of a virtual world, so you're building virtual factories and seeing how robots interact with each other and bump into each other and figure out how those AI factors, or how those real world factors can actually work, or you want to have physical robots taking autonomous action in the real world. That's physical AI, but that's kind of the ultimate evolution of where we're trying to go, allowing robots to take autonomous action, or again, simulating the physical world inside of a virtual environment. That's where we're trying to go. And to throw some numbers out there, so 50% of organizations are going to try, or they're getting value back from generative AI. They're using agents inside their walls. 40% are seeing reductions in cycle time and getting productivity. But the real stat I want you to walk away from this presentation with, and specifically on this slide, is that by 2028, a third of all enterprise software applications will have some form of agentic AI buried inside of them. That means we need to start building these AI factories now to start handling the compute requirements that are going to happen in 2028 when agentic AI is really starting to get infused into all these different enterprise software applications. I'm going to walk through some slides here in a second that kind of go through what are these compute requirements and why is it so resource intensive, especially from an inferencing point of view. But keep that in mind, a third of all enterprise software applications will have some form of agentic AI by 2028. That's a key thing to remember. So let's talk about our scaling laws for a second. So before 2022, we cared about pre-training scaling. So this is training foundational models, this is training deep learning models from scratch. We were throwing all of our resources at figuring out how we could better scale training models from scratch. We called that pre-training scaling. After generative AI, where there's two scaling laws that we really started to care about. One is post-training, and the other is what we call now test time scaling, which is really inferencing. The reason these two scaling laws matter is because we found out if you take an untuned open source LLM, like your Llamas, your Mistrals, your DeepSeeks, and you try to apply those directly towards your business data, you're gonna have a very high hallucination rate, and you're gonna have poor context of answers, what we call context efficiency for those answers. And so for folks that don't know what a hallucination is, so an LLM, the job of an LLM is to finish the paragraph, finish the sentence that it's writing. If it doesn't know the answer to something, it will make it up. It won't stop and say, I don't know the answer. It won't give you some kind of prompt that says, I don't know, I can't find the information on this. It'll just complete the sentence by making up information. And for an untuned, unpost-trained LLM, it can hallucinate up to 30% of the time. And it can likely not give you the right relevant answer that you're looking for in the business context that you're trying to ask it. Poor context. If you had an employee that gave you made up answers 30% of the time and gave you very poor contextual answers, you wouldn't be very happy with that employee. That's why post-training, that's why test time scaling matters, because now you can do post-training on these open source LLMs. So instead of having to train these LLMs from scratch, you can grab an open source model, do some post-training on it, apply some RAG to it, and therefore now you can actually get better answers. You can reduce that hallucination rate. We have some data now that says something around 21%. If you apply RAG to an open source model, you can reduce the hallucination rate by 21%. Same thing with getting better answers by being able to claw back into your organization's data through RAG to be able to get better answers. But we are seeing massive amounts of tokens being generated at each of these stages. So in the pre-training stage, we're looking at 20 trillion tokens. Post-training, trillions of tokens per model, hundreds of thousands of post-training models happening out there. In the test time and inferencing world, hundreds of thousands of tokens, hundreds of millions of queries per month. We're seeing just massive amounts of tokens being generated. But here's where the data gets interesting. So in the post-training world, we found that when you need to post-train, it requires 7 times more compute than it costs to train the original model. 7 times more compute. Now there's different things that are happening in that pre-training phase and then compared to the post-training phase, but 7 times more compute is required to post-train the model than it costs to train the original model. So you need to have AI factories to be able to handle this post-training requirement. And again, you want post-training because it reduces the hallucination rate, gives you better context for your answers, more relevant answers for your business. Here's the thing that really blew my mind. So another thing that we're doing, we want to turn what we call AI reasoning on in the inferencing stage. We found that it drastically reduces the hallucination rate and improves the context of the answers. The problem is that it costs 100 times more compute to get to that final answer. And just a quick refresher on what AI reasoning is. So in a typical prompt and answer, LLM situation, you have your prompt and you have your answer. One step, single pass. For AI reasoning, we ask the LLM to take multiple loops. We ask it to ask multiple questions, get better context, and to give you a better answer. But it costs 100 times more from a computational perspective to get that done. And frankly, we all thought inferencing was going to be easy. Computationally, it's easier. You can use lower mathematical precision. It's a single pass to the neural network. There's no back propagation step. So we all thought inferencing from a mathematical perspective is going to be easy, but this changes the game a little bit. We start turning reasoning on and asking the LLM to take multiple passes through itself. So as a quick example, this is kind of where we got the data from, where we had a prompt trying to figure out the seating chart at a wedding. And we asked it, with reasoning off and reasoning on. Reasoning off gave a very poor answer. It sat people next to each other that shouldn't be seated next to each other. It didn't seat as many people at the table as it should. I think it miscounted the tables as well. But the point here is that we generated roughly 400 tokens. But when you turn reasoning on, 8,000 tokens, so 20 times more tokens, but 150 times more compute. So when you have agents interacting with each other inside of your walls, when you have employees trying to get relevant contextual answers that aren't hallucinating, you're going to want to turn reasoning on. Reasoning costs 100 times more compute. When you want these agents talking to each other, you want the agents to be as accurate using the right tools, you turn reasoning on to allow them to do that. This is what's going to be computationally intensive into the future, and this is why AI factors are really going to be necessary. So I mentioned that stat, 1/3 of all enterprise software applications are going to have some form of agentic AI. You're going to want those agents to be as accurate as possible. You're going to want to turn reasoning on, but now we see 100x computational increase. And so that kind of blew my mind a little bit in terms of how much compute is really required to build these AI factors, but that's why you need them. But there's some good news. AI factories at their core are supposed to generate value for your organization. So that means the more you invest, the more you get back. CTOs, CIOs typically see IT data centers as cost centers today. But if you can transform them into AI factories, something that's producing value for your organization, now the more you invest, now the more you get back, the more you want to invest, the more you want to get back. It's a different type of conversation. So AI factories, theoretically, again, manufacturing value for your organization. And under the hood, here's some key differences. We talked about how we want to drive towards more of a profit center, go from retrieval to generative, but under the hood, we want to move from x86 CPU-based architecture towards accelerated-based architecture to handle these resource loads coming. We potentially want to increase the amount of power per rack. We understand inside enterprises there could be some issues with trying to do that, but that could be something that can help. Move towards liquid cooling, but the real piece you need to pay attention to is the networking. So most traditional IT data centers, north-south traffic is what you care about, and in this example, we needed roughly 100,000 NICs to do that. For an AI factory, you want these GPUs talking to each other, so east-west traffic becomes incredibly important, and what it does is it quadruples your networking requirement. You go from 100,000 to 400,000 NICs. To be able to satisfy that networking requirement, and you want to purpose-build your AI networks or at least purpose-build kind of the fabric of the networking for AI. Because if you don't, now you're going to have GPUs sitting idle. they're not going to be utilized. They're very expensive, obviously, and you're going to have poor utilization rates and poor kind of ROI and AI factors. So you want to think about the networking costs, the networking architecture on top of all this as well as you're building these AI factors. But this is kind of the key differences. But we want to transition from the left to the right. We want to transition from traditional IT data centers to AI factories. And some good news, though, is that we are starting to see, massive kind of, on-prem starts kind of, a lot of people starting to bring workloads back on-prem a little bit more. I think something like 86% of CIOs and CTOs said they're trying to bring workloads back on-prem. And one of the key drivers for that is AI. So you want to rebuild some of these traditional data centers into AI factories into the future to kind of handle some of these resource requirements. Okay. And so some of the major challenges that we're going to be talking through here are, there's design complexity on top of that, obviously deployment and cost, but time to value is what you're going to be thinking about as well. How fast can you bring these AI factories online to be able to satisfy the compute requirements for AI agents into the future? One of those tools is NVIDIA AI Enterprise. And something that we've announced earlier last month, or I think it was later last month, is this idea of government-ready or kind of offline-ready NVIDIA AI Enterprise software. Before October, if you wanted to use the NVIDIA AI Enterprise stack and get access to our NIMs, our NEMOs, our the AI queues and all that, that helps really drive performance on top of all these different AI workloads, you have to run them, kind of in kind of an online type of setup. And so, but we were able to enable this to be able to run, in a sovereign environment and a more at-scale environment. So the idea here is you can have just as fast development times for your organizations to build AI factories and kind of build AI workloads in an offline environment as you do online. So that's kind of what we're bringing to market, and something that we're working with HPE a lot to bring sovereign AI factories to market through our software stack. And in my opinion, this is the secret sauce for NVIDIA. We have very powerful GPUs, we have very powerful networking on the hardware side, but the thing that really makes us shine is our software. That's the thing that really brings performance to the table, and being able to actually give you real-world AI workload performance by being able to give you optimized performance through the software. And then HPE is going to come along and allow you to actually connect that to your business and start receiving value back. But that, again, like the main value add here through our government-ready or kind of our offline-ready NVIDIA AI Enterprise stack is being able to accelerate your time to value, so you can go just as fast as those folks that are in the private sector. And you also get to use the best of breed technology out of NVIDIA to be able to build these things from scratch. And so here's some of the compounding effects of all of our investments into building AI factories. So we obviously have our AI Enterprise and run AI, then we ensure that we can have very performant AI performance on top of all the different hardware, but also also ensuring that we have a high GPU utilization rate, very high energy efficiency, very high performance, and then going down to the network as well to be able to feed the GPUs as much as we can. Let me go forward a little bit. And so that's, I think that's all I want to go through. So keep in mind, the thing I really wanted to talk to you about today was, why AI factories are truly necessary. Again, keep that data point in mind. A third of all enterprise applications, software applications, by 2028 are going to have some form of agentic AI buried inside of them. Massive resource requirements coming down the road for these. And so this is kind of why you need to think about building AI factories and to be able to kind of prepare for that stage and be able to handle all those different kind of software applications that are coming in. So I'm going to hand it off to Terry, who's going to kind of go through, again, how we actually connect these systems to your business through either at-scale or sovereign. Terry.
Thanks, Steve. So Steve kind of gave an insight to the complexity and how you actually make the complexity more simple. And we're going to talk a little bit about how HPE works with NVIDIA to actually do that simplicity. So let's start first of all with the most predominant customer demand and customer requests that we get when it comes to AI factories and how we actually define an AI factory. First and foremost is the ability to provide multi-tenancy. And when we say multi-tenancy or you discuss multi-tenancy, it's always important to understand what type of multi-tenancy. What does that entity mean by multi-tenancy? It can be as simple as segregating workloads through name partitioning on a Slurm-based cluster, extending into something as complex as fully air-gapped solutions and everything in between. And so the way we deploy multi-tenancy is that we do it at the name partitioning level, We do it at the container CNI level. We implement it at the fabric level using PKI key encryption for IB, for InfiniBand, or VXLAN for Ethernet. But we also extend it into the storage tier to really do composable clusters. So as you get into environments that may be doing sovereign work, more sensitive government research, or you have high levels of confidentiality, or you have different brands that obviously need a segregation at the highest level, we can facilitate that at the extreme of air-gapped all the way down to name partitioning and everything in between. But fundamentally, it's a comprehensive approach to multi-tenancy across the fabric, the storage tier, the compute tier, the container tier, and then obviously the namespace partitioning as well. Second is that it needs to support variety of workloads. What do we mean by that? So today the focus is predominantly generative AI, moving to agentic or intensively on agentic, not physical, as Steve mentioned. But there's still many customers that are doing traditional machine learning, traditional time series data analytics, deep learning type of approaches as well. In addition to that is we have companies that do legacy and traditional high performance computing workloads, computer fluid dynamics, simulation mod, thermodynamics, right? Finite element analysis. And what we're finding now is that that world of traditional high performance computing, traditional workloads is really converging with AI. So using agentic systems and AI reasoning models to look at outputs of traditional HPC workloads is a huge domain that's increasing in investment and research and in benefit as well. So you can improve the accuracy of the simulation. You can improve the speed to that. You can provide recommendations on how to improve that. You can even preemptively look at the architecture for a traditional workload in HPC context with AI to preemptively set it up to the best configurations to have the best possible output as well. So when we say mixed workloads, it is everything from traditional high-performance computing workloads all the way through to time series data analytics, machine learning, deep learning, generative AI, agentic, and physical. So it needs to be able to flex that, and that can be things like floating point analysis, it can be things like throughputs, latency sensitivity. All that really has to go into the design and the forethought around what the workloads are and the outcomes that the particular customer entity is looking to achieve. Second is the ability to deploy and integrate in a simplified way. So there is a lot of complexity, but fundamentally, you want to be able to provision at scale. You want to orchestrate and provision the infrastructure seamlessly. You want to instantiate tenants and multi-tenancy easily. You want to have insights into the system and how it's being used as well. So we simplify that through a common control plane and through user interfaces as well, and we'll double click on that in the next slide. The other aspect is service catalogs. Every large enterprise or medium-sized enterprise wants to be able to service different lines of business. One line of business might be using PyTorch, the other might be using TensorFlow, one might be doing traditional machine learning, the other might be doing generative AI focus, and they have different tool chain sets. And so the ability to interface to a single portal and really automate and provision those nuances, those preferred tools that are relevant for that particular line of business, to particular data sets, to particular GPU libraries, to particular frameworks, is very important to be able to automatically deliver that, just like you would have in the cloud, in a seamless automated provisioning way at scale as well. So that's the cloud-like experience that we bring on-prem. Then we look at the usage metering. So from an operational standpoint, we see a lot of traditional IT divisions that are now providing GPU as a service. And then they're moving up the stack to provide the machine learning operations, the data operations, and then the tool chain sets and the PaaS and SaaS platforms that may be associated with those workloads to the enterprise as a whole, or within a sovereign context to a country or a research development or to a particular program as well. And so the ability to fundamentally have insight into how the system's performing, how it's being used, preventing over-provisioning, making sure that that system is running to its most efficient manner is critical as well, because using the system efficiently is really what gives you the metrics to measure ROI. It also gives you the metrics to sustainability. So you can improve sustainability through power and thermals and all the things we see with the data center evolution, but you can also add to sustainability by using the system well. If you run an intensive, long workload, but the outcome is accurate and the outcome is what you need, that means you don't have to run 10 more instances of that workload, and that also contributes to efficiencies and to sustainability. So that insight on the performance and the usage are critical. And then last but not least is the security. So hand in hand with multi-tenancy, today we see AI becoming more as a service like any other traditional IT out there, like database as a service or email as a service. IT will ultimately become a service that will be delivered out to lines of business, to employees, or in the sovereign level to different entities that are part of that sovereign ecosystem. And so with that, you have to look at authentication. You have to look potentially at packet sniffing. You have to look at firewalling, vulnerability assessment, and all that typical cybersecurity aspects, especially with regulatory movement now, protecting data. All of those aspects become critical, and we bring a whole comprehensive solution set from a consulting perspective, partner ecosystem, and tool chains as well that help accomplish the full sort of evolution and cycle of the cybersecurity domain as well. So these are all the key things that customers want and need, and some have more priorities or emphasis on one or the other, but this is what we see across the world at the moment. And so how we actually bring this to the market and how we work with NVIDIA to actually deliver this is we first bring the infrastructure. That includes the compute, the storage, the GPUs, the CPUs, DPUs as well from NVIDIA Bluefield, as well as the fabric, be it IB, be it Ethernet, and then also the data centers. So air-cooled, liquid-cooled, or hybrid solutions of that, modular data centers as well. And that's all the critical, durable foundations that you need. And it's very important to understand that as every generation sort of accelerates on GPUs, that you are going to have to scale with that. So that means maybe at some point today you can survive with air cooling. Ultimately down the road, you're likely to have to employ direct liquid cooling to support the next generation of GPUs as well. From an operating layer, there we go. From an operating perspective, we bring containerization, bare metal, as well as hypervisor for virtual machines as well. So we'll support any sort of open flavor or CCNF compliant Kubernetes flavor, from Red Hat OpenShift to others to SUSE Rancher and others. And we can provide a little bit of flexibility in that approach as well. And then we have developed a control plane in a combination of a company that we acquired called Morpheus, not the NVIDIA Morpheus product, but Morpheus Data, which we acquired, that powers our GreenLake engine, in addition to things like Ansible automation and a couple of other partners that provide FinOps capability, help manage the fabric, or provide insights and performance visualization. And we use things like Prometheus and Grafana as well to do that visualization. But fundamentally, the control plane provides the catalogs that are customized to the end users so they can provision and get the data, the libraries, and the tools that they need in a consistent way. It authenticates them through RBAC. It manages the containers themselves, associates the containers to the different composable storage clusters to provide that multi-tenancy, provides usage metering of the system itself and visualizes that, can integrate the traditional IT services like LDAP or ADSM, any of the traditional IT authentication capabilities as well. And then the multi-tenancy with that, and if needed, we can also connect that to the public cloud as well. So that combination of control plane with automation on top of the OS is what brings that automation, orchestration, intelligence to life. And then we provide a seamless, on the northbound, we provide a seamless integration capability into tool chain sets, including NVIDIA's, which we'll highlight in a second, but think of any LM as a service, think of model context protocol, hosting repeatable projects that have been successful so that other lines of business or other entities can go and look at that project, immediately get access to those tools, those models, the way that it was fine-tuned, et cetera, or how it was doing reasoning, and they can leverage that for the next project as well. So that concept of hosting projects, models, and reusability becomes important as well. And all that comes into how we deploy the AI Factory. And last but not least, the security, as I mentioned, the lifecycle operations, obviously, to support feature releases, especially if you're doing compliance to security standards. In the States, we typically have for federal type entities or private companies working with federal entities, we have things like NIST 800, CMMC standards, and those have to be continuously maintained and updated as well for compliance. So that's something that we implement through the life cycle operations as well. And then observability, obviously, on how the system's performing and who's doing what. And so one other thing I just want to highlight here is that we also fully integrate with the NVIDIA stack. So from a southbound perspective, we can implement DGCM, we can implement the fabric integration, and everything else that's needed from the provisioning perspective and access to the CUDA libraries. We then bring in the base control manager, command manager as well. We integrate that into the control plane. We are working on NVL 72 as well for mission control. And fundamentally the UFM fabric, NetQ, and everything else that goes with that. So you're fully interoperable with NVIDIA's entire stack from an infrastructure provisioning and CUDA library perspective. But then on the northbound, we also bring in NVIE. We can implement Run AI as a scheduler and a memory optimization capability, and we can also bring in the NIMS capability and the NVIDIA AI for Enterprise suite as well. And we continue to refine this. Right now, we're actually focused, all this is in place and ready to go, but now we're working as well with NVIDIA on bringing in DPU Bluefield technologies to really help facilitate the ability to provide the GPUs at a VM level and carve up the GPUs as well. Today, we do it at the node level for multi-tenancy. Very soon, within this year, we'll probably have that ready to go at the VM level so you can actually carve up the GPU and provide that to different lines of business or different customers. So we've kind of covered the control plane. I'll highlight one last thing. The way that we see this being consumed is, fundamentally, you could start at the infrastructure level, right, at IaaS level, and that really is bare metal GPU clusters, GPU as a service, with really validated reference architecture. So we have a very intensive internal program that does reference architecture development. We start at sort of 128 GPUs, then we go to 256, then we go to 512, 1024, up to thousands of GPUs with proven architectures, topologies like Dragonfly and Fat Tree that we know work and are designed and developed to support specific workloads as well. And we do that hand in hand with NVIDIA. So that's the tier 1 level. Then you could potentially move up from tier 1 into a phase 2 where you bring in GPU as a service and manage Kubernetes with a little bit of segregation. Moving into tier 3 at a later point for multi-tenancy, bringing the self-service catalogs to your users, and then providing that automation custom to your environment. I think that's the important thing to understand about AI factories is that no one AI factory works for everybody. Everybody has levels of brownfield, levels of greenfield. They have reusability of software assets that they want to integrate. That is part of the scope that we do for systems integration. And then moving into the 4th level where you then start moving into things like model hosting, project hosting, LM as a service, token as a service, et cetera, and then integration of different toolchain sets as well as we moved into agentic and having that be available in a seamless automated way to your end users as well. So we have customers that absorb this at tier 1. We have some customers that go all the way to tier 4 on the first day of the project and some in between as well. But it is modular, so you can absorb and compose and evolve as what's needed by your environment and your level of preparedness as well. And so from a persona perspective, the way that we kind of carve this out from an interaction perspective, we have the infrastructure provisioning administrator who really provides all the resources, sets up the GPUs, the storage, the networking, and everything else, provides the container capability. We have the tenant manager, tenant administrator, which will actually set up the tenants, provide the tools, and customize the tools to those users and those tenants. The MLOps engineer that will actually be responsible for bringing in MLOps capability, data ops capability, potentially if we move up to tier 4, the LM as a service type of functionality as well. And then you have the end user itself. So if you think at a very simplistic level, a very simple example, I have a data scientist, an ML engineer, or a developer that wants access to a certain thing. So they log into the user portal authenticates them, says what they can do, what can they access, what are the resources that they can get. That then invokes automation through Ansible. Ansible will go out and will pull the GPU libraries that they need. It'll then give them access to the database, data lakehouse, or data warehouse that they need for that particular data set. It will then go out and provide them the IDE of choice, TensorFlow, PyTorch, et cetera, and give them access to the models that they need as well. And you could, as an example, invoke a security framework quietly in the background to monitor and provide XAI capabilities for reproducibility, explainability. All of that gets seamlessly done through that automation flow. So that's a very traditional example of how a user would interact with the system to get access to their resources. And then that configuration can go into a configuration management database, and you can use that CMDB to then provision that scale and repeat that for different lines of business and different projects as well, and provision that continuously at scale. And I think we're kind of we talked about the isolation of multi-tenancy, so I'm going to skip past that. But fundamentally, I think the last thing, just, if you think about AI factories, please think of NVIDIA and HPE as the partnership that really provides the full stack functionality. So it's not just the GPUs, right? It's everything up to the control plane, the orchestration, the application layers, it's the security fundamentals, it's the consulting capabilities where they're needed as well. And we bring the full power and strength of the NVIDIA software stack, and we're tightly integrated and working together to make AI factories what they really are. And that is the convergence of high performance computing with AI, and now with IT services, and with security requirements. That's really where the entire ecosystem is going towards, and that's what we bring fundamentally through the stack. We've deployed this. It's in production with many customers. We can demo it. We can enable POCs. So if you have interest, please get hold of Steve and myself. And I think with that, Steve, we're going to see if there's any Q&A that we want to take.